Do you want faster execution of SQL queries? Do you want maximum control over how your SQL queries are written? Do you want a simpler experience when working with an object relational mapper? If you answered yes to any of these questions, you might want to consider using Dapper, which is a package in the .NET ecosystem that is classified as a micro-object relational mapper. So it's classified as a micro-ORM because it's basically just a layer that sits on top of ADO.NET, which are basically the core classes in .NET for data access. And it also doesn't have all the insane features that Entity Framework has, such as change tracking, caching, SQL query optimization. Dapper is much simpler, as we will see in this demo. So for this demo, we are in our ReserVim application, which I did a full series on building. Be sure to check that out. But for this application, I used Entity Framework as my ORM. So I have a couple services, actually 3. I have a reservation provider, a reservation creator, and a reservation conflict validator. And all of these use an Entity Framework DB context. So what I want to do for demonstrating Dapper is replace all of these services with a Dapper implementation. And we're going to see how to set up Dapper, execute queries, and also scaffold out a database, because Entity Framework does have migration. So here on my application startup, I actually run this migrate, which will scaffold out and create the database if it doesn't exist. Dapper does not have this advanced functionality. It is a micro-ORM, as we recall, so we're going to have to set this up manually. But before we can even do that, we're going to need Dapper. So let's head into managing NuGet packages for our project, and we are going to search for Dapper. So just plain old Dapper, we will install that. And just looking over here, there's a bunch of different extensions too. Just from glancing through the documentation, a lot of these seem pretty useful, but we're not going to get into those here. We are just going to focus on Dapper, but I'll leave a link to the Dapper docs that describe some of these extensions. So back in our application, the first thing we have to do in order to do any kind of database interaction is connect to the database. So over in our project, I am going to create a new folder, I think. Let's do that, and we'll call this DB connections. So connecting to our database, and let's put a new class in here. For this demo, just for simplicity, I'm going to be connecting to a SQLite database. So let's call this the SQLite DB connection factory. And you could always extract this to an interface if you wanted to connect to different databases. But all this class is going to have is a single method to create a DB connection. So an IDB connection from system.data. I was going to call this method create, but how about connect? So we call connect and we get a connection back. That makes sense. And all we're going to do is return a new SQLite connection. So that is from Microsoft.data.SQLite. Import that, and that takes a connection string. So we're going to get that connection string as a field into this class. So let's generate that field for a connection string, read only, and then we are going to get the connection string through the constructor. So it's nice getting the connection string through the constructor rather than through the method parameters, so that everything that uses this DB connection factory doesn't have to pass in the connection string. It can just call connect and get its database connection. Doesn't have to worry about that connection string. So we have the functionality to connect to our database. Let's register this class in dependency injection. So let's just do that right here. We can add this as a singleton and just instantiate our new SQLite DB connection factory and just pass in our connection string here. And this connection string is loaded from my app settings.json. Let's see what that is. So it is data space source equals a reservim.db. So just wanted to show that off in case you are following along. So now we can all happily connect to the database. Now that we can connect to the database, let's initialize it and create some tables. So this is going to be pretty much the equivalent to migrating the database, except we don't get the benefit of migration history. But over in our project, let's create a new folder. We'll call this DB initializers. I promise this is the last folder. We have so many folders in this application. Ideally, I'd have this like split up into multiple projects, but just wanted to keep it simple. So let's create a new class in this folder. We'll call this the SQLite DB initializer. And I am specifically stating SQLite here because some databases might have to be initialized differently, such as a SQL Server database. You might have to actually create the database, then create tables. SQLite is a little bit simpler, as we will see. So we'll just have a single function on here. We'll call it initialize. And we're going to have to connect to our database. So let's get our SQLite DB connection factory as a field in this class. Import that. And we'll get that through the constructor. And let's create our DB connection. So the IDB connection, import that as well from system.data. This is going to be our database. And we'll get that from our connection factory. So just connect, and this DB connection is going to have to be disposed so that we're not infinitely hogging the database. So we'll just surround this in a using statement, so it'll automatically get disposed when we leave this block. And now let's take our database and let's do some Dapper. So honestly, initialization isn't really that fun. All we're going to do is use execute, so import that from Dapper, and just pass in some SQL that we want to execute. So this SQL is just going to create our database table if it does not exist. So let's define that SQL up here. So a const string, we'll call this the create reservations table SQL. I actually have one table in my application, so just one SQL statement that we have to write here. In fact, I probably should have demoed the application. We'll do that in just a second, but let's write this statement. So we are going to create a table if it does not exist. So if not exists, the table name is reservations, and the structure for this, we have an ID, which is a text type and is the primary key. We have a floor number, which is an integer, and whoa, this statement is getting way too long. Let's move to the next line. So let's do an enter right there, and that's kind of weird with the plus. I don't like that. So what we can do instead is put a little at before here, and now we can move this to a new line. Let's actually move all this to a new line. And let's get back to writing this. So we also have room number, which is an integer. And I actually forget what the other fields are on my reservations. Let's look at this reservation DTO. And we got username, start time, and end time. So username, that's going to be text, username. And then we have start time and end time. And believe it or not, in SQLite, start time and end time are just text fields, just looking at the documentation just now. So that's another reason why you might have a different DB initializer for different database types. Because in like SQL Server, I think there actually is a specific date time type. But anyways, let's indent this, make it look a little bit nicer. And now let's execute this SQL. So just plop it in there. It'll execute it and create our database table. And also our SQLite database file will get automatically created on our first connection. So we will see that. But first, let's head into our app.xaml.cs. So back in dependency injection, I'm going to add another singleton, and this will be for our SQLite DB initializer type, which we just created. So import that. And now on application startup, let's remove this database migration logic from Entity Framework. So we can just delete that. And now let's take our host services and resolve this SQLite DB initializer, which we just registered. Let's put that into a field, and let's take that initializer and initialize. So that should create our database and create our tables. So let's head into the bin, which is where our database file should go. Here we go. I got it highlighted right here. Let's delete it. So this is the one that was generated with Entity Framework. And let's run our application and see our database file get generated. So let's put a breakpoint here before we execute. All right, about to execute. No database file yet. Let's step over this. And we got our database file generated. It has some size, so those tables should be there. And while I'm here, I'll demo the application real quick before we start converting this over to Dapper completely. But we got no reservations right now. Let's make a reservation. So singleton Sean, floor 1, room 2. And let's submit this with the default start and end date. There we go. We reserved our room. And now it appears on our view reservations page. We can also have conflicts. So if I try to make a reservation for a room that has already been taken for a specific date range, then we will get this room is already taken on those dates. But if we try a different date range, so a date that hasn't been taken, then we can reserve the room. So all this data is stored in the database that we just created, except right now we're using Entity Framework to interact with that database. But for demo purposes, we want to convert all of that over to Dapper. So the first service we're going to translate over to Dapper is our database reservation provider. If we look at this, all it does is query all of the reservations from our reservations table. So it should be pretty simple to implement in Dapper. So over in my services folder for reservation providers, we're going to add a new class here. And I know I called this the database reservation provider originally, and we're still interacting with the database, but I'm going to call this one the Dapper reservation provider. So let's implement reservation provider. There we go. And first off, we know we're going to have to connect to our database. So let's get our DB connection factory in here. So a field for a SQLite DB connection factory, import that, throw it in a field, and get that field through the constructor. And now let's get our connection. I'm just going to copy this from the SQLite DB initializer. So just copy this using statement and plop that in here, import everything we need, and import Dapper. Except this time, instead of using execute, which just returns the number of rows affected, we don't want to do that. We want to get some row data back. So we want to execute a query, which is part of Dapper, and we're going to query async because this is a task, so we want to execute that asynchronously. And the type that we're querying for our reservation DTOs. So this is just my simple data transfer object type that translates reservations between my application and my database. So let's import that from our DTOs namespace. And now if we look at query async, it gives us back an IEnumerable of reservation DTOs. Let's get those. So an IEnumerable of reservation DTOs, and we have to await this and make this method async. Now we got to write our SQL to get our reservations. Let's put that in a const again, a const string. We'll call this the get all reservations SQL, and we'll do our little @ symbol in front. So we can have this as a multi-line string, and we'll select star. So selecting all the columns from our reservations table. And let's clean this up a little bit. So actually it might be a good idea to move constants like this, like the name of the reservations table, which we also used in the SQLite DB initializer. It might be a good idea to move this table name and maybe even the column names into some kind of file of constants just to ensure consistency. But we'll keep it simple for now. That's just something to keep in mind. Let's use the SQL though. So pass that as the SQL for our query. And now this method returns a bunch of reservations, so not reservation DTOs. So we will have to map these DTOs to our reservation domain object. And I do have that mapping logic in my database reservation provider. So I'm just going to copy that over for now. Ideally, that would be in a different class so we weren't duplicating it everywhere, but just focusing on Dapper for now. So what we're going to do is return our reservation DTOs, which we will map using select to a reservation. And let's put a breakpoint here and test this out. Before we can do that, we have to head into our app.xamarin.cs, and now our iReservation provider that we use all throughout the application is going to be a Dapper reservation provider. And let's try this out. All right, here we go in the Dapper reservation provider. Let's step over this query and we get an exception. So it cannot cast from string to GUID. So that's probably on the ID. If we look at reservation DTO, so our ID is a GUID, and I believe the reason for this is that the underlying ADO.NET cannot automatically map from string to GUID. So what we're going to have to do instead is let's create a different DTO. So instead of reservation DTO, let's just copy this and we'll rename it to Dapper reservation DTO. I could probably just change this existing one, but I don't want to mess with any of the existing code in this code base. So create this new Dapper reservation DTO. Let's open that up. We're going to call it the Dapper reservation DTO. And we don't even need these data annotations. That's specifically for Entity Framework. And now ID is a string instead of a GUID. And now the Dapper reservation provider is going to query for Dapper reservation DTOs. Let's fix that, update that in this method. And now we should not have any problems here. It should be able to map since it's just a simple string. Let's step over this, and there we go. We get our reservation DTOs. And there's our data, perfect. So it looks like it was even able to map the start time and end time into date time. So that is perfect. Thank you, Dapper. Let's continue. And there's our reservations. But this was like the simplest query of all time. Let's try something a little bit more challenging. So I also have this reservation conflict validator that'll give us back a reservation that conflicts with the reservation that we're trying to make. So if the room number and floor number are the same and the incoming reservation's time overlaps with the existing reservation's time, then it is considered a conflict. So let's implement this with Dapper, and as you can already see, this is a much more advanced query. So this one's going to be fun. Let's create a new class in our reservation conflict validators. Again, keeping with naming conventions, we'll call this the Dapper reservation conflict validator. Let's implement our iReservation conflict validator interface, make our method async. We're going to need our SQLite DB connection factory again. So I'm just going to copy that over from the Dapper reservation provider that we just created. Let's copy that, paste that in here, update the constructor, import everything we need. Let's get our using statement copied over here as well, import everything we need, and now we're ready to go. Let's implement this query. So we are going to take our database and query again. Let's import query, except this time we're going to do a query first or default async. So we're going to try and query one reservation, and if we can't find the reservation that we're looking for, it'll give us back null. So we are querying for our Dapper reservation DTO. That is the DTO that maps to our database table. So we'll get back that DTO from this method, the reservation DTO, and we'll have to await this query since it is async. And now let's write some SQL for this query. So I know what you might be thinking, it's such a pain having to manually write out these queries, but that is what it takes to get the great performance of Dapper, and it can be very beneficial when working with more advanced queries, such as with many-to-many relationships, which are such a pain in Entity Framework, but much simpler when you can just write out the raw SQL. So let's write out that raw SQL. This one will be the get conflicting reservation SQL. That sounds good. Another multi-line string. Let's do that. We're going to select all the columns again. So select star from our reservations table. And now mapping the logic in our entity framework query. So we want the floor number and room number to equal. So in SQL, just a simple where clause. So floor number needs to equal a floor number parameter that we're going to pass in. So you might think, okay, maybe we'll just do some string interpolation here or like a string format, but you actually don't want to do that because that leaves us vulnerable to SQL injection attacks, which probably isn't an issue in our simple desktop application here, especially since we're not dealing with any string types in this query, but it's better to follow best practices, especially since SQL injection could really mess things up. So we are going to use the parameter syntax here. So we're going to have a parameter for floor number, and we want the room number to equal our room number parameter, and we want the start time to be less than the end time. So we'll have an end time parameter, and then we want the end time to be greater than the start time. All right, very good. So now let's use that SQL down here. Let's move this on the new line so that we can see it. And now since we specified parameters on this query, we are going to have to pass those in using this param object. So the param object that we pass in has to have properties that match these properties. But rather than defining a class that has those properties, instead what we can use is an anonymous object. So we define an object right here. We'll just call this parameters. Then we can just instantiate a new object and define just an anonymous object type here and just throw on the property names that we want. So we want a floor number to equal our incoming reservations floor number, which is on the room ID floor number, and then room number to equal the room number on our incoming reservation, and then start time will equal the reservation's start time, and then lastly we got end time from our reservation end time. So very magical, feels almost like JavaScript, but not quite. But now we have an object that has the properties that will get plopped into these parameters that we have, so let's pass that in. The parameters. And now if we cannot find a conflicting reservation, then reservation DTO will be null, and we'll just return null from this method. But otherwise, we're going to return our reservation. So we're going to have to map our Dapper reservation DTO to a reservation again. So same mapping logic that we have in the Dapper reservation provider. Again, should probably not duplicate this, should probably move it to a class that we can reuse it. But just for simplicity, let's go ahead and just paste it in here. And then we'll map our reservation DTO to a reservation and just return that from this method. And let's put a breakpoint here. Back in the app.xamarin.cs, let's replace our database reservation conflict validator with the Dapper version that we just created. And let's try this out. So we're going to make a reservation that conflicts with this reservation. So floor number will be 1, room number will be 2. And it will be on the 1st through the 8th, so that's just the default. And here we go, we should conflict. So we're going to check first, do we get our parameters set up? Let's make our query, and we get back the existing reservation that conflicts with us. So we should return that, and we get this room is already taken on those dates. Let's change our room number and try again. And I removed my breakpoint, but the reservation DTO was null, and we returned null, did not have a conflict. So now, we've seen queries, we've seen some advanced queries with parameters. How about inserting data? So I have my reservation creator, which is what we use to make reservations using Entity Framework right now. Let's do this with Dapper. So in my reservation creators folder, let's create a new item, the Dapper reservation creator, implement our reservation creator interface, make our method a sync. We're going to need our connection factory. So let me just copy this again and paste it in our reservation creator. We need our using statement as well. So let's just snag that, import everything we need, and update our constructor. And creating a reservation will be pretty simple. So we can take our database, and using Dapper, we can just execute some SQL. So let's import execute from Dapper. There's no specific insert method because we don't really need a specific insert method. We just need to execute some SQL. So this SQL, let's define that. The insert reservation SQL. So we're going to insert into our reservations table. And what are these field names? So we got ID, floor number, room number. Let's specify that. ID, floor number, room number. We got username, start time, and end time. And the values for those fields are going to be parameters that we pass in. So we're going to pass in an ID. And in fact, let me just copy all of these and just turn those all into parameters. All right, all good. We're ready to use the SQL. So let's use that for our execute method. And again, we are going to need a parameters object. So let's get some parameters in here. Just another anonymous object, which I just love. I probably wouldn't recommend using these very often, but I feel like this is the perfect use case. So we're going to have an ID parameter, which is going to be a GUID. Let's generate a GUID. And like we saw before, Dapper was unable to convert a string to a GUID. Not sure if it could convert a GUID to a string, but regardless, I'm just going to call toString on this GUID, so we don't have to worry about it. Then we got a floor number, which is going to be the incoming reservation's floor number, which is on the room ID. Same thing with the room number, get that parameter. Then we got username from our reservation, and start time from our reservation, and end time. So all the parameters we need, let's pass those into our query. And actually we need to execute this asynchronously so that we don't block our UI. And we should be good to go. Let's put a breakpoint here. Back in the app.xaml.cs, let's get rid of our database reservation creator. Use Dapper here instead. So in fact, we are fully Dapper. We don't need our reservation DB context factory, which uses Entity Framework. We don't really have any more Entity Framework, I believe. And yeah, we are fully Dapper. Let's see this in action. So we load our reservations. Let's make a reservation. So no conflicts, we will submit. And this room is already taken on those dates. Maybe that is a conflict. Is it? Oh yeah, it is. I already made that last time. All right, let's try again. So we're going to do room number 4 this time. Let's submit. All right, creating the reservation. So execute that. And all good. Let's continue and see our created reservation. There we go. Perfect. Obviously, with this execute async method, you can pass in other kinds of SQL operations such as updates or delete froms. So we've seen the core functionality of Dapper. It is faster, but regarding speed, I wouldn't recommend just going through and removing Entity Framework and replacing it with Dapper just for speed, because we're talking milliseconds here. If you really need those milliseconds, maybe it's worth it, but most likely you probably don't. We also get to write our own SQL, which is great. We get full power. So if you run into like a many-to-many operation that you need to do, it's not going to be a pain like it is in Entity Framework. But on the contrary, if you know nothing about SQL or your team doesn't know much about SQL, maybe Dapper isn't the best option. I would probably recommend learning SQL. I think it's essential to know. But even then, we are losing out on the optimizations of Entity Framework. So I'm not really like a SQL expert. Like there's some crazy people who could probably optimize this query. So that's just something to keep in mind. There are pros and cons to being able to write your own SQL. But regardless, the simplicity of Dapper makes it really nice to work with, especially since a lot of the times I don't even use the crazy stuff that Entity Framework has. Really, all I need to do with an ORM is query the database and get some data, or either execute some kind of operation, which Dapper allows me to do with its powerful micro-ORM abilities. So we've covered the essentials of Dapper. We've even compared it with Entity Framework along the way. So if you're interested, you are now ready to leverage Dapper in your own application. If you have any questions, criticisms, or concerns, be sure to leave them below in the comments section. If you enjoyed the video or are enjoying the channel, consider becoming a member. Other than that, leave a like or subscribe for more. Thank you.